Cool. I guess we're gonna get started. So thank you guys so much for coming. 大家好，很高兴回到上海。Today we're going to talk a little bit about modern data scientists, or modern data science and data science pipelines, and how we can take advantage of Kubernetes and other cloud-native technologies to make this process a lot more reliable and faster. Let's see. Cool. Before we get started, all the code, examples, everything's going to be on my GitHub. I'll tweet about it too and stuff. So first thing is the process. We start with data science. We have a business need or problem discovery, customer issues. Then we go into the development phase. This is where we get that raw data. We understand what's going on. We iterate through and build our models and try to make the most accurate models we can. And finally, and most importantly in most cases, is we get to production. We hit that point where that model actually impacts the user. And it's the whole process that we want to look at. We've gotten pretty good at this development phase. There's a lot of tools and technologies we have now to go either, if we're more advanced, to go deeper and deeper into our data to have a full understanding, or on lowering the barrier to entry so anybody can take advantage of machine learning and this data science. So the only issue with that is this is in the entire process. If I have the best model of all time, the most accurate model, that doesn't do me any good if it doesn't actually touch the customer. There's a lot of reasons for why this process becomes complicated. If you look at modern data science workflows, we have to get raw data, extract it, put it places that we can actually use it in databases, the ETLing. Then we have to actually train our models, evaluate them, understand what's going on. And finally, we have to be able to serve those models and have those results ready. And anybody setting up these manual pipelines realizes it's a complicated process. There's a lot of things to manage and things that can go wrong. And so moving forward and looking at what we have today, we have the managed VMs and the infrastructure. And before this was challenging with bare metal until cloud providers came. Now we can get VMs relatively cheap and easy. But then we have a problem of managing those resources. As we all know from this conference, that's where Kubernetes comes in. We now don't have to think about virtual machines and understanding those. It can just manage those for us. But the problem is, as we saw from that pipeline before, in data science, there's a lot more involved in that. And so now we need a data infrastructure management layer to help go through that pipeline and understand the data going through it. So today we're going to talk about Pachyderm. And Pachyderm is one of a good example of using native Kubernetes to tackle this problem of having data science pipelines and management. And so Pachyderm has two main components to it. Number one is a data versioning, so version control system for data, which is extremely powerful, and we'll talk about that in a little bit. And two, it has language agnostic pipelines, which means I can set up these declarative pipelines, just like a pod spec or a deployment spec of the state that I want, and then use containers to transform our state. And so let's take a common example of one of those pipelines is something like this. All pipelines in Pachyderm have a name. Then you have the most important section is the transformation. So this transformation section, we give a container, we can version this container, which is extremely important, and we also give it a command. So anybody who knows pod specs or deployment specs, this should look very familiar. And then we have an optional section, which is parallelization. We're going to go deeper into this later, but this allows you to specify if I want multiple replicas of my pods running. So this gives a lot of power in pipelines to be able to do multi-processing. And finally, we have an input section. And this allows us to directly figure out how we want to expose our data to our containers. And we'll see a lot of the power of that later as well. So now looking at a pipeline like this, it's not as complicated anymore. We have to have these manual bash scripts to set up and manage it manually. We can have our JSON files live in our code base alongside, where our infrastructure is then reviewed and understood by our team going forward. So this pipeline can be set up just like Kubernetes deployments in seconds. And so now, before we really dive deep into understanding how to implement these pipelines in Pachyderm, we're looking at 4 data science principles to help us along to make it a little bit more reliable in our processes. So the first principle is just autonomy. As a data scientist, I want to be able to go into a project and use the languages and tools that I want to. So whether it be Python for data visualization or Go for my processing, and not have to worry about making it adapt to my infrastructure. And so there's a lot of ways to do that, but we also want to focus on being able to manage, so as a data scientist, to not have to have an extreme experience in data science as well as infrastructure. So I don't need 20 years of experience in distributed systems to be able to set up these good pipelines. At the end of the day, we have specialized skills. We want to be able to focus on those specialized skills. And doing that, it should be pretty obvious now, is we use containers. So Containerization, there's tons of good talks yesterday, tons of good talks today about how we can containerize it. And in data science, there's really only two main sections that we want to focus on. And number one is single operation per container. And this is pretty obvious in other containers, but for us, we wanted to talk about, so if I have a model and training that model, that should be a container. If I have evaluating that model, in many cases, we want that to be a separate container. As we'll see later, setting up these pipelines, having these separate containers gives us a lot of granularity and understanding our process and how data flows through that process. And number two, we want to parameterize our data inputs to that container. So what this means is we want to be able to have exactly what data is going into our container and where it's pulling from. And this is because Pachyderm exposes data to these containers in something called the Pachyderm file system, the PFS. And this means this has two advantages in Pachyderm. Number one is when I'm testing my containers locally, I'm reading from a CSV or a local file, which is pretty common. And now my production environment, my code is doing the exact same thing, is reading from these files to understand what's going on in the data. So that means instead of having a production database and then locally I'm doing files and having to change these interfaces, there's a lot of problems prone with that. Where this means my local development environment is as close as possible to my production environment. Number two, it allows us to take advantage of that parallelization that we saw in our deployment specs. So now Pachyderm, if anybody's familiar with Hadoop or these MapReduce problems, this is a way you can do a lot of these applications in a Kubernetes native way. So now I can spin up multiple instances of my container, and then Pachyderm will manage partitioning the data between those and sharding the data. Another cool thing about that is not only can I process faster, but if, say, one of my VMs goes down and I lose a piece of that, Pachyderm, when Kubernetes spins the pod back up, Pachyderm will then process just that data that hasn't been processed yet. And so this becomes very powerful in our pipelines. So now, principle two is reproducibility, and this idea of having data versioning. And another one of those really interesting concepts. Because you can't, if I asked anybody in this room when the last time they started a coding project without Git, I mean, it's almost crazy. Yet something like data that's arguably more volatile than code, nobody thinks twice about it. And so this allows us to do a lot when it comes, whether it be for the developer, where I can now go through a process and understand exactly the transformations I'm making to that data, or for my team. So I don't have to make these copies of databases. I can now branch off data from my coworker and have a full understanding of exactly how this is going on. Or for production, as I can do different sanity checks and debugging in production, understand exactly how my data is flowing. I was talking to one group of data scientists that they were doing predictive models on a user database. And every single data scientist there, and every single different operation, they would make a copy of that database. And that seems, if this is something that's very familiar to you, this is something that's very, very hard to work with. Not only do you have stale data, we don't know how long ago this data has been copied from the main source, but also as we make these transformations, what transformation has been had to that? So when you build these models off of that data, you don't know how it's been affected or how it's going to affect you in the production. So now this leads into probably one of the most impactful things that having these pipelines and having version data is something called data provenance. And this is essentially when you have a version control data repository that feeds into your pipeline and then feeds out into another controlled, I can now track that data through. That means when you have a predictive result at the end, so I have a prediction for my model, I can now track that through every single iteration of my data all the way back into the raw data that was put in there. And this has some amazing effects on your workflow. Number one is I can retry after failure. So now in those pipelines, if I have a failure happen, I don't have to send it through the entire pipeline again. Setting up these manual processes where a lot of cases I have timing between my data. Now I can just, Pachyderm automatically knows, okay, that failed here, restart, just process the new data. I can do rollbacks. Say I have some bad data that gets some biased data that gets put into my process and goes through my pipeline. Now, all I have to do to redo the entire pipeline is remove one commit. And then it can manage going through that entire pipeline flow. And that's extremely powerful. No more having to go back and trying to find old versions that were saved. You can now just do this automatically into your CI/CD pipelines. And finally, and probably most importantly, is it gives clarity into your organization. So now you can see exactly how data is affecting your organization, exactly what things are happening. So that means if I have bias, I can track bias in my algorithms and everything. So the final thing we were looking at is automation, is how do we really go through and employ these data science pipelines into our CI/CD workloads. In this cloud native world, we're already pretty familiar with doing this automation. And so now it's just as important to have our pipeline infrastructure alongside our code base to go through the same review process and things we're used to in our normal day-to-day operations. And so today I'm going to use Azure DevOps, but any kind of like Jenkins, there's GitHub Actions is going to be, I'm excited about going forward. And so to go through this review process, we have autonomy to really make it so we have as much developer action as we can. As a data scientist, shouldn't have to be looking through all these workflows. Number two is reproducibility, that we can now track exactly the changes made to our data, which is at the end is our most important thing as data scientists in machine learning. Next, we have data provenance to be able to have clarity in our organization, to have the full understanding of how everything's happening. And finally, to automate the process, to remove that manual work from what we're doing. So now let's look at an example. So we're going to use a very common data set, the iris data set, so good for classification. Anybody who's not familiar with it, there's 4 different petal lengths or features, and then classification. And we do hyperparameter tuning. So we're going to have our raw data. We want to split that data into training and test, build a whole bunch of different models with different parameters. And then we want to evaluate each model, and finally select that model. So in the Pachyderm terms, or what our pipeline is really going to look like, is we have a data repository for our raw data that's going to allow us to track the changes that we make and how we add it. That's going to go into a pipeline that splits us into training and testing. That's going to go into another pipeline that's going to use the training data to train a whole bunch of different models with different parameters passed in as well. And those parameters, the same way, are version controlled. Finally, we're going to evaluate those models and then select the best models based on the threshold. And anybody who's used to setting up these kind of data science pipelines, it can be very complex, and there's a lot to go into it. So let's take a look at what exactly we need for Pachyderm. Let's go back. So here I have my 4 different pipeline specs. We can see, so here's my model. All I'm doing is I have a simple Python script that's SVM for anybody's curious. We'll go deeper into that in a minute. But I loop through the input data that I have, in this case, my raw data file, or the CSV that has my training data, and then my parameters that I want to test that against, and run the command. And the most important thing here is this parallelization spec. So in Pachyderm, there's 2 ways to parallelize. I can either set a set number, so maybe 4 replicas, or in this case, I'm using something called a coefficient. So this is taking advantage of the resources in my cluster. In this case, since I have 2, it's going to run 2 instances of this for any node in my cluster. In this case, I have 3 nodes in a cluster, and we'll see the difference of that. And then I expose my raw data. So in this case, I want my training data, every single container, and then I want to partition or shard my parameters, of which parameters to go. And so they're very similar for the other different pipelines. I'm not going to go through those, but all that's required to set this up is these simple commands. Now, Pachyderm uses very similar to Kubernetes, has a pack control. Here, all we'd have to do is create our repositories. Then we add the data in. In this case, I have a single file for my parameters that I then split into multiple files. This just helps to when I do the distributions. And then finally, I create the pipelines. So now, instead of having each manual step going through there, that's all it takes. And so let's take a little look at actually implementing that. So there I'm just running the script. It's creating the repository, adding the data, and then finally it's going to create the pipelines. So that's the coolest part about all of this is just Kubernetes. So all the tools that you're used to with tracing, and we're going to see in a minute, kube control, it's just spinning the pods in your cluster. So if you want to go deep into that, you have full control. You can see everything in your cluster. So we see here that it spins up a different pod for an entire pipeline. Now here we have a few options. You can either have these pods always running, so your pipeline is ready to go if you have some streaming data or quick data that you need to constantly process, or you can have it set up to just when you need it to, just to spin up resources when it's needed, and then spin down those resources when they're not. So this gives a lot of advantages to like the virtual kubelet project, so I can spin off those resources into a serverless architecture. And so once we see those pipelines start to run, we can use the pack control to start looking at these jobs being executed. So in this case, we see that our first job, the splitting, training, testing, it saw that there was data added to our raw data repository. So then it started executing the pipeline, in this case, splitting into training and testing data. Next, it started to train our models. And I think there's 77 models that it shows. and it's going through and training our data through there. And so it detected that there was new training data, and so it executed that pipeline. So no more waiting. Like I've seen a lot of data science pipelines go where you wait 8 hours or try to make it, and so you have to make those timings. Because of the version control, it will automatically track through there. And so now that finished, so once the models were finished and added to the model repository, it automatically kicked off the evaluation pipeline. And so now it can evaluate all of those pipelines and move forward. And then once that's finished, it'll go into doing the selecting. So this is nice, but that doesn't take advantage of the automation. This is still I don't want to have to manually go out and update my pipelines each time. So now we're going to go through an example of being a developer. In this case, you can be a data scientist and not have to really focus on Kubernetes concepts or anything. I can push up to GitHub, run run my CI tests and do everything, and then have it being deployed out to my cluster. So we can see what that looks like. So here I have a PR with some small model changes. Then I can push it. It automatically triggers a build in my CI/CD pipeline. In this case, it's going to pull down the source code, build my containers, then push that container to my container repository, and it versions these through, so I can now track the builds in the source code, exactly what caused that container. And then it's going to do it's going to replace in my Pachyderm files and do my deployments out to my cluster. And what's really cool about this is Pachyderm is automatically going to know that the model has changed. And so it's going to start processing starting at that point in my pipeline. So we don't have to reprocess all the data going through there. We can just focus on the piece that's changed. So in this case, we don't have to resplit our data into training and testing. It can just focus on the new model being created. So as this video is going, so we go a little faster. And then once all of that build goes through, we can do those releases where we release automatically to the development environment. And going through this, it gives us a much faster deployment process with our models. Now we can confidently test in production what our model is doing, what it's like. And when we're confident, we can release it into staging or production. And so here we see that this was our old pipeline that was going through. It succeeded. And it's automatically detecting the changes in our pipeline and executing those jobs and builds. And so a really nice thing about this is, so here's the Python script or the model that I'm actually using. And so it's an SVM. I take in my parameters, my inputs, like we talked about before. We want to really parameterize that input and output data as files. Then I simply am running and training the SVM. And so as a data scientist, I don't really have to understand, even go through Docker and those things yet. I can push it up, it'll train, and it'll build my Docker image, and then push it to the container registry. And so hopefully this gives you a lot more ideas of some power you can do with Pachyderm and setting up these pipelines. Obviously, this is a very simplistic case with a pipeline, but having all the transformations be fully tracked throughout the process. And then you can link in with maybe Kubeflow and do different kube servings or multiple training if you're talking more of the neural networks. And so this process, having this automated process, can really help speed up and be more reliable to get out and be impactful for your customers. And so with that, if anybody has any questions or any ideas on going forward with the pipelines, I'm the only one with Sam Kreter, so it's really easy to find me. Twitter handle, GitHub, Medium, anything. So also come down afterwards and talk. I'd love to hear your ideas and what you're doing. With that, thank you so much, and have a great KubeCon.